Imagine a world where the skies burn with acid rain, the air is thick enough to crush you in seconds, and the surface is hotter than a pizza oven set to maximum. Welcome to Venus, Earth's evil twin. At first glance, this planet seems almost familiar, with its similar size and rocky composition, but don't be fooled. Beneath its shimmering, cloud-covered facade lies a hellscape of volcanic plains, suffocating carbon dioxide, and temperatures soaring to a blistering 475 degrees Celsius, 900 degrees Fahrenheit. Yet, despite its hostility, Venus holds secrets that could rewrite the story of our solar system. Was it once a habitable world with oceans and life, or is it a cautionary tale of a planet consumed by its own greenhouse effect? Join us as we unravel the mysteries of Venus, the hottest planet in our cosmic neighborhood, and discover why this fiery world continues to captivate scientists and dreamers alike. The story of Venus begins billions of years ago, in the swirling chaos of the early solar system. Born from the same cosmic nursery as Earth, Venus emerged as a rocky planet with a similar size and composition. For a fleeting moment in its infancy, it might have even resembled Earth, a world with vast oceans, a temperate climate, and perhaps even the potential for life. But somewhere along the way, Venus took a dark and dramatic turn, transforming into the scorching, hostile world we know today. This is the tale of Earth's evil twin, a planet that challenges our understanding of habitability and serves as a stark reminder of the delicate balance that makes our own planet thrive. As the young Venus cooled, water vapor in its atmosphere condensed, forming oceans that may have covered much of its surface. Scientists believe that for nearly 2 billion years, Venus could have been a habitable world, with conditions not too different from early Earth. But as the sun grew brighter and hotter over time, Venus's fate began to unravel. Its proximity to the sun, about 30% closer than Earth, meant it received far more solar energy. This extra heat caused its oceans to evaporate, releasing water vapor into the atmosphere. Water vapor, a potent greenhouse gas, trapped even more heat, triggering a runaway greenhouse effect that would forever alter the planet's destiny. The once blue skies of Venus turned into a thick, suffocating blanket of carbon dioxide. Today, Venus's atmosphere is 96% carbon dioxide, with clouds of sulfuric acid swirling high above its surface. The atmospheric pressure on Venus is a crushing 92 times that of Earth's, equivalent to being nearly a kilometer underwater. If you were to stand on its surface, you'd be instantly crushed by the weight of the air, while the scorching temperatures of 475 degrees Celsius, 900 degrees Fahrenheit, would melt lead and vaporize organic matter in seconds. It's a world where the very air is poison, and the ground glows with the heat of an inferno. Despite its hellish conditions, Venus is a planet of breathtaking beauty when viewed from afar. Its thick clouds reflect sunlight so effectively that it shines brighter than any other planet or star in the night sky, earning it the nickname the evening star or the morning star. These clouds, composed of sulfuric acid droplets, create a permanent overcast that obscures the surface from view. For centuries, astronomers speculated about what might lie beneath this veil, imagining lush jungles or even civilizations. But the reality, as revealed by space probes, is far more alien and awe-inspiring. The surface of Venus is a volcanic wonderland, dotted with thousands of volcanoes, some of which may still be active. Vast plains of hardened lava stretch across the planet, interrupted by towering mountains and deep canyons. One of its most prominent features is Maxwell Montes, a mountain range that rises 11 kilometers, 7 miles, above the surrounding terrain, higher than Mount Everest. The planet's surface is also marked by strange, pancake-shaped domes called phaera, formed by the slow oozing of viscous lava. These geological features hint at a turbulent past, where volcanic activity reshaped the landscape on a massive scale. Venus's extreme environment has made it a challenging target for exploration, but humanity has dared to venture into its fiery embrace. In the 1960s and 1970s, the Soviet Union's Venera missions achieved historic milestones, becoming the first spacecraft to land on Venus and transmit images from its surface. The Venera probes revealed a rocky, desolate landscape, bathed in an eerie orange glow with sharp rocks and fine-grained soil. These missions, though short-lived due to the planet's harsh conditions, provided invaluable insights into Venus's atmosphere and geology. More recently, NASA's Magellan mission used radar to map Venus's surface in unprecedented detail, revealing a world shaped by volcanic activity and tectonic forces. The data showed evidence of past plate tectonics, suggesting that Venus may have once had a dynamic crust similar to Earth's. However, unlike Earth, Venus lacks a global system of plate tectonics today, which may have contributed to its runaway greenhouse effect. Without the recycling of carbon dioxide through tectonic activity, the gas accumulated in the atmosphere, trapping heat and sealing the planet's fate. One of the most intriguing mysteries of Venus is whether it ever harbored life. Some scientists speculate that in its early, more temperate days, Venus could have had the right conditions for microbial life to emerge. Even today, there is a tantalizing possibility that life could exist in the planet's upper atmosphere, where temperatures and pressures are more Earth-like. In 2020, researchers detected traces of phosphine, a gas associated with biological activity, in Venus's clouds. While the discovery remains controversial, it has reignited interest in the possibility of life on Venus and spurred calls for further exploration. The future of Venus exploration is bright, with several missions planned to unravel its secrets. NASA's DAVI-NCI mission aims to probe the planet's atmosphere and analyze its composition, while the VERITAS mission will map its surface in greater detail. The European Space Agency's Envision mission will study Venus's geology and climate, providing new insights into its history and evolution. These missions could answer some of the most pressing questions about Venus. Did it once have oceans? Was it ever habitable? And what can its extreme climate teach us about the future of Earth? Venus is more than just a cautionary tale. It is a testament to the incredible diversity of worlds in our solar system. Its story reminds us of the delicate balance that makes Earth a haven for life and the potential consequences of disrupting that balance. As we continue to explore Venus, we not only uncover the secrets of our cosmic neighbor, but also gain a deeper understanding of our own planet and its place in the universe. Venus, the hottest planet, and Earth's evil twin, remains a source of fascination and inspiration, challenging us to push the boundaries of exploration and discovery. The exploration of Venus is not just about understanding a distant world. It's about piecing together the puzzle of planetary evolution and the forces that shape habitability. As scientists prepare for the next wave of missions to Venus, they are driven by a profound question. Could Earth one day suffer the same fate as its fiery twin? The parallels between the two planets are impossible to ignore. Venus serves as a stark reminder of the fragility of planetary climates and the potential consequences of unchecked greenhouse gas emissions. By studying Venus, we gain insights into the mechanisms that drive climate change, not just on other worlds, but on our own. One of the most compelling aspects of Venus is its atmosphere, a swirling maelstrom of gases that defies easy understanding. The planet's upper atmosphere moves at astonishing speeds, with winds reaching up to 400 kilometers per hour, 250 miles per hour, a phenomenon known as superrotation. This means that the atmosphere circulates the planet much faster than Venus itself rotates. Scientists are still trying to unravel the mysteries of this atmospheric behavior, which has no direct parallel on Earth. Understanding superrotation could provide clues about atmospheric dynamics on exoplanets, expanding our knowledge of how weather systems operate across the universe. Another enigma lies in Venus's volcanic activity. While the planet's surface is littered with evidence of past eruptions, it's unclear whether any of its volcanoes are still active. Recent studies have detected signs of potential volcanic activity, such as transient hotspots and changes in atmospheric sulfur dioxide levels. If Venus is indeed volcanically active, it would be a groundbreaking discovery, offering a glimpse into the planet's internal heat and geological processes. Volcanism could also play a role in replenishing the planet's thick atmosphere, contributing to its extreme greenhouse effect. The search for life on Venus, though speculative, remains one of the most exciting avenues of research. The detection of phosphine in the planet's clouds has sparked a heated debate among scientists. On Earth, phosphine is produced by microbial life or industrial processes, raising the tantalizing possibility that Venus's atmosphere could harbor microbial organisms, while alternative explanations for the phosphine signal have been proposed, such as unknown chemical reactions or volcanic activity. The discovery has underscored the need for further investigation. Future missions could analyze the cloud particles directly, searching for organic molecules or other signs of biological activity. As we look to the future, Venus also holds promise as a potential destination for human exploration. While its surface is far too hostile for human habitation, its upper atmosphere presents a more inviting environment. At altitudes of around 50 kilometers, 30 miles, the temperature and pressure are similar to those on Earth, leading some scientists to propose the concept of floating habitats, essentially cities in the clouds. These habitats could serve as research stations, allowing scientists to study Venus up close while testing technologies for living in extreme environments. Such a mission would be a monumental achievement, pushing the boundaries of human ingenuity and exploration. Venus is more than just a cautionary tale or a scientific curiosity. It is a world of endless wonder and mystery. Its story is one of transformation, from a potentially habitable planet to a scorching inferno, and it challenges us to rethink our assumptions about planetary evolution. As we continue to explore Venus, we are reminded of the incredible diversity of worlds in our solar system and the delicate balance that makes Earth a haven for life. Venus, Earth's evil twin, is not just a distant neighbor. It is a mirror, reflecting both the beauty and the fragility of our own planet. And as we unlock its secrets, we take another step toward understanding our place in the cosmos. Venus, Earth's evil twin, stands as a haunting reminder of how delicate planetary balance can be. Once a world that might have mirrored Earth's oceans and skies, it now burns under a thick, toxic atmosphere, its surface a volcanic wasteland. Yet, its mysteries beckon us. Could life exist in its clouds? Was it ever habitable? As missions like DAVINCI and Envision prepare to unveil its secrets, Venus challenges us to understand not just its past, but our future. It's a testament to the fragility of worlds and a call to protect our own. Venus, the hottest planet, remains a beacon of cosmic curiosity.